Okay, good afternoon. Today's aim, what evidence do we have for erosion? Do now says, write for 3 minutes. Scientifically speaking, what is going on in this illustration? Give you a moment, take a look at that image, come up with a conclusion. Mini lesson, we're going to talk about erosion methods, and for the activity it says erosion lab. It's actually more of a climate lab, but you'll be seeing that in a few moments. Summary, share out discussion, and then lastly, for homework, you have a Newcastle Learning assignment which will be due this Friday. So taking a look at the image here, it says, when I was a kid, all of this was fields. So old man talking to a young kid. So basically, what's being said here? Erosion is the removal of rock from the earth by breaking it down and usually casting it out to the ocean. Now, the rock can be redeposited onto other parts of the earth. This is where we see deposition. But think of it like you go to the bank, you deposit money into a bank account, that's your deposition. Erosion is the breakdown that happens before. Okay, so before we talk any further, let's talk about displaced sediments. So anytime you have sediments that are being picked up from one location and brought somewhere else, they're being transported, also known as displaced. For example, you might find granite boulders atop limestone bedrock. We find this here on Long Island. We find this all over the place with glacial erratics, really large boulders that have been dropped off during the last ice age when a giant sheet of ice traveled across North America, leaving basically boulders on Long Island. Let's take a look at some rock characteristics. Running water is one of the biggest things that erodes and weathers rocks. How do you know these rocks have been weathered by erosion? What characteristic can you notice on them? Well, they're round. The rounded off edges on there are going to show that water probably played a role. They're probably bouncing down a stream for hundreds, thousands of years. The other thing is the fact that they're smooth. The smoothness of them shows that they've been broken down by abrasion. And the fact that they're all in one spot is that they were transported, also known as eroded away. Wind also plays quite a big role. If you take a look at the two images here, the one on the left, you can see the very smooth, polished surface. The one on the right is a little bit more pitted, but you also see the smooth texture. Wind picks up particles of sand and then sandblasts the rock. What you'll also notice is that you'll see here, there's kind of like a curve, and then this spot isn't broken down. It's because sand gets picked up and it doesn't really travel that high. Same thing in this case. Sure, you're going to see them rounded off, but you're going to see more erosion on this lower area. Gravity is a huge role, a huge force involved with the breakdown of rock. And in fact, a lot of the times you can tell gravity did it because the rocks are angular. These rocks here fell down a cliff, broke, and now they're jagged edges. Glaciers, basically you're going to find striations, streaks, and usually you'll find a lot of glacial polish, which is just polished rock. And again, this we find very similar to the wind-blown, sandblasted rock. So a bit of review from earlier in the week. We have some ice wedging. Water gets into a crack. It starts to expand. It breaks apart the rocks. Some rocks fall, right? The one on the right, again, water got in there, froze, broke it open. Now, I want you to imagine what would happen if an acorn fell into this crack, or a seed fell into this crack. Well, that's right, you get a tree growing through it. Now, on both these images, especially the one on the left, maybe 100 years ago, an acorn fell through into that tiny crack and literally burst open this boulder. Exfoliation. You have when, usually this is caused by temperature differences, when the outermost layer of the rock gets broken free from what's below. If you were strong enough, you could literally pick up that sheet of rock and it would lift free from the bedrock below. Now, there's a lot of other reasons that cause it. Primarily, it's temperature differences. The way that I remember exfoliation is I think about those commercials for beauty creams and face scrubs. Usually they have like pumice or sand or something in it, and they talk about how it exfoliates your skin. It removes the dead layers. Abrasion, we could see that rock gets broken down. See all the pitting. In fact, this could also be used for geologic time. Which rock is probably the youngest? Probably up here. Who's older? Who's older? Who's oldest still? Oxidation. Oxidation is just a fancy way to say rust. And if you take a look at this image here, these mountains, these plateaus have rusted. It's funny to think about it, but in many places on Earth, there's a really large concentration of iron inside the rock, and that iron can cause rusting, oxidation, that leads it to look red. Basically, if the rock looks red, there's a good chance that there was iron in it at some point. Carbonation. In this illustration, we see coal miners. If you find coal, odds are that thousands of years ago, that, or more like millions and tens of millions of years ago, that area was a jungle. Jungles that get buried over by deposition and sediment, the plant material breaks down and turns into this rich, dark rock we call coal. That's basically it. Today's activity is going to relate to the Köppen climate classification system. This is actually a lab. I know it says Part C at the top. It's kind of related to the one that we did prior, but I'm skipping over Part B. But Part C here, basically I'm going to give you the quick rundown. A gentleman by the name of Köppen came up with an idea of how to classify the Earth's major climate regions. He has here A, B, C, D, E, and F. A is tropical humid, which means hot and wet. B is dry. Notice it doesn't say hot and dry. I know we like to think of deserts as hot, but that's not always the case. It's just dry. It could be cold and dry. We have mid-latitude, mild mid-latitude, which is pretty much us. Severe mid-latitude. We have polar, which is cold. Doesn't necessarily mean wet and cold, or doesn't necessarily mean dry and cold. And then lastly, we have H for highland. Highland is basically representative of how the higher altitude you go, usually the drier it gets and usually the colder it gets. Now I'm going to let you read through the rest of this yourselves. If you need to use the internet to answer some of the questions, that's fine. Most of it's right here. I know the paper might be a little bit difficult to read, but just do your best, read through this. This lab will be due on Friday. Alright. And basically here we have these charts that show the precipitation versus temperature, and really these are the two we're looking at. So if you take a look at this location, they usually get precipitation and it's usually pretty warm. Okay. With this location they get lots of precipitation and the temperature gets cold in January and it gets warm in July. So you can kind of guess where on Earth these places are. So like let's say for example location C, it's at a pretty high latitude. Well, not that high, it's around 30-40 degrees north. So they get warm summers and they get cold winters and they get a good amount of precipitation. Alright, so that makes sense. So you could basically look through this yourself. Again, due date on this will be Friday. Alright, thank you very much. I will be back on Monday, it looks like. So I will see you 1 week from, well, actually this video will be going out tomorrow, which is Tuesday. So I'll be seeing you on Monday.